Hello 8th grade, I am Mr. Rogers and you are watching the video notes for section 2-2 on how to read and interpret the periodic table of elements. So right here in front of us we have the periodic table of elements. You can see there's a lot going on. I'm sure some people look at this and go, hey man, what's going on in here, man? I see Y39. Y39, it's like a football call. Y39, ready, sit, hut. So it'll be yttrium there, yttrium. Also, though, other numbers across the top, 3A, 4A, 5A, what do they all mean? Why do we have 1 way up here? Why do we have, would be 118 way down over here? So there's a rhyme and a reason to why things are where they are on the periodic table. There's a reason why Y39. There's a reason why it's right here. And that's what we're going to talk about today. So some things to think about. We talked about before are valence electrons and what are valence electrons. So some things we're going to notice about the periodic table when we're done is kind of a question here. So what do you notice about the number of valence electrons as you move from left to right across a row or period in the periodic table? So the number of valence electrons would be the outermost electrons. They had like sodium, magnesium, aluminum, silicon, here. What's going to happen is they're going to go up by 1 for the most part. What do you notice about the number of energy levels as you move down the group or column? So as you move down, energy levels are going to go up. So 1 energy level, 2 shells, 3 shells, 4 shells, 5 shells. Those are some of the big things we're going to try to figure out as we look at the periodic table. So some things we need to know about the periodic table of elements is how it's put together. Why is it arranged the way that it is? And the biggest reason is by the atomic number. And the atomic number is the number of protons in the nucleus. So in the periodic table, the elements are arranged from left to right and top to bottom by increasing atomic number. That is a very important idea of why this is put together. So copy it down, highlight it, put a star by it, smiley faces, whatever you have to do, but know the fact that the periodic table is arranged by increasing atomic number. And so when we do that, we get some things happening here. Some patterns start to emerge. We get families or groups, and like a family, they have a lot of the same characteristics. So families in a periodic table, they're in that same up and down column, and they have the same number of valence electrons. So if I go back here real quick, in this group, this family up and down, they all have 1 valence electron because of where they are partially also. Or over here, this group all has 8 valence electrons because they're all in the same family. The other way you kind of arrange them is by a period, a row across the periodic table. They have the same number of electron shells. Remember, it goes 2, 8, 18, and that outer one is always going to be 8. So the same number of shells. So just by looking at the periodic table, we can pick out a couple of big facts here. So we can see, look over here, we can see how many electrons they're going to have based on where they are. We can tell how many, like our Bohr models, how many shells they're going to have. All just based on where they are in the periodic table. This creates these groups and families. So you are going to put this next slide right here, put this drawing. And again, I'm not going to necessarily put anything on the screen. You've got to hear this to know what to put it in your notes. This is kind of important. This kind of goes over the different types of families and what's going to happen. So each family, like alkali metals, will be over on the far left-hand side. Again, they have 1 valence electron. And here's the dot diagrams down here. For whatever the element might be, you can put those in the middle. But you can see the black dots here represent the number of valence electrons. So depending where you are, what family you're in, the oxygen family all the way down is going to have the same. They're going to have 6 valence electrons. The halides, fluorine, chlorine, and there's also bromine, iodine. They're all going to have 7 valence electrons. So depending where you are, we can tell a lot just by where you're located in the periodic table of elements. Now, the other thing we need to know is there's also color-coded a lot of times into different ways. One basic way it's color-coded is by one of 3 different types of elements. Some elements are metal. You can kind of see them here in our light bluish color there, turquoise-ish color. These are all metals. A lot of elements are metals. Here we have our metalloids. That means they kind of have some properties of metals and some of non-metals. They're kind of also called transition metals. But over here, more in our yellow, these are non-metals. So like oxygen, it's a gas. It's not a metal. Hydrogen, again, is a gas, not a metal. It's also broken up in these 3 ways. And as we start binding things together, we're going to notice that metals certain bonds create metals with metals, certain bonds are metals and non-metals. So it's good to know what's a metal and what's a non-metal. All right, so for a quick recap, if you have a periodic table here, again, it's arranged by atomic number. And atomic number is always here, remember, up above the symbol. So increasing atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when we do this, we get an arrangement of, if you're in the same group or family, the same number of valence electrons. And also periods across the periodic table going across, they have the same number of electron shells going across down the periodic table. Some of the basic arrangements of a periodic table, guys. So we're going to stop there. We thank you guys for watching, and we'll see you along the way.